Welcome to SynerJEE online classes. Today I will take up the topic of double titration in the stoichiometry chapter. Why I have selected this double titration topic in stoichiometry in order to explain. In many years of experience, I have seen especially students find difficulty in understanding the titrations topic in the stoichiometry chapter. Especially in the titrations, double titrations, I've seen many students find difficulty in understanding it. So that's why I have chosen this topic so that it will be helpful for many aspirants. Before understanding this double titration concept, we need to first understand some basics related to the indicators. Suppose if I take litmus pH 7, below pH 7 it is red in color and above it is blue in color. It does not happen with all indicators. Suppose if I take an indicator which is phenolphthalein. Suppose phenolphthalein if I take as indicator. Now in this phenolphthalein, don't expect that pH less than 7 it is colorless and more than 7 it is pink. Yes, basic it is pink, we know already, but and acidic it is colorless, but it does not mean that less than 7 pH it is colorless and greater than 7 it is pink. No, even if a region falls somewhere here, suppose a point is falling here which is pH greater than 7, but still according to the phenolphthalein it is a acidic point only. So actually from here to here, all this portion, it is a colorless portion for the phenolphthalein, because some slightly above pH 7 also, those points as far as phenolphthalein is concerned, that is treated as a acidic point, because every indicator has a range. Every indicator behaves in a different manner. So depending upon the range of the indicator, these points will fall in the colorless region. So these other points above pH 8, these points will fall in the pink region. Now, if you take the methyl orange as indicator, for example, if you take methyl orange, let's call it MO. Now here also don't expect that pH less than 7 it will be red color and pH greater than 7 it will be yellow color. We know that methyl orange is red in acid medium and yellow in the basic medium, but it does not mean pH less than 7 it is zero, it is red in color. Here up to certain this region only it is shown red color, and after that portion, whatever other portion is there in all this portion, it is yellow in color. That means only this region. So if a point falls in this region, it treats that point, that pH point as acid. Suppose if something falls here which is beyond this region, then although it is still acid, but methyl orange treat that compound at that pH as a base, so it shows a yellow color. So this basics you have to understand, especially with phenolphthalein, methyl orange. This is sufficient to answer the double titration problems. Now let's go into the actual topic of double titration with this understanding. Now see, mostly the problems are revolving around the Na2CO3 and NaHCO3 and NaOH in the case of double titration. Find the quantity of these substances. Now for example, suppose if I take a solution containing NaOH and Na2CO3. If these two compounds are present in an aqueous solution, now you need to find its quantities. Let's say these quantities are unknown and X millimoles and Y millimoles are present. Normally we will deal in laboratory with the less quantities. That's why I have taken millimoles. You can take moles also and solve accordingly. It does not matter. Now, when you add the corresponding reagent which can react with these things, okay, Before adding this substance, actually we use the acid substance, normally HCl or H2SO4 we will use in order to titrate with this NaOH or Na2CO3 beaker solutions. Now before adding this acid, we add an indicator into the beaker. That is what we do in the experiments in the laboratories. So if you add indicator, there are two indicators are available for phenolphthalein and methyl orange. Let's take phenolphthalein is added into the beaker. So I am taking phenolphthalein as indicator. You have added phenolphthalein indicator. So when you add phenolphthalein as indicator, phenolphthalein shows pink color in the basic medium. Therefore, you will see here a pink solution. Okay. So when you take a pink solution, now add HCl into the beaker. When you add HCl, what are the reactions takes place? First, HCl react with the strong acid. First HCl reacts with the strong base. Which is a strong base here among NaOH and Na2CO3? NaOH is a strong base. So first HCl reacts with it and forms NaCl and H2O. Now since X millimoles of NaOH is taken, so it reacts with X millimoles of HCl. Fine. After NaOH is consumed completely, then Na2CO3, the second better base here after NaOH, begins to react with HCl. When it reacts, it forms first NaHCO3. Now, actually NaHCO3 is an amphiprotic compound. It can act as a base, it can act as acid also. Now, Na2CO3 after reacting with HCl forms NaHCO3. NaHCO3 is a weaker base compared to the Na2CO3. Therefore, once until total Na2CO3 is completely reacted, NaHCO3 do not begin its reaction with the HCl. So it waits till total Na2CO3 is completed in the reaction. So once the reaction is completed, then what is there in the beaker? NaCl, NaHCO3 and H2O is there in the beaker. And NaHCO3 is a weaker base, weak base. And its pH is close to 7. Not 7, it will be close to 7. It is 7 point something values will be there. 7.5 like that, its value will be there. So since it is close to 7, and if you use phenolphthalein as indicator, we already know this here in the phenolphthalein process indication. So if a point falls here, then phenolphthalein treat it as an acid and exhibits colorless solution. So therefore here, since it is a weak base and pH is close to 7, so phenolphthalein treat it as a acid and it will show colorless solution. So this should exhibit. Now solution turns into colorless. We have started with pink color, but now it has turned into colorless solution. Now this now at this point, what is there in the solution? NaCl is there, bicarbonate is there, and water is anyway there from the beginning because water is the medium here. Now what is the quantity of NaCO3? See, since Na2CO3 is 5 millimoles, it reacts with 5 millimoles of HCl to form 5 millimoles of sodium bicarbonate. So NaCO3 is 5 millimoles present. There is no NaOH and there is no Na2CO3 at this point because both are reacted. NaOH completely reacted, Na2CO3 also completely reacted. The remaining thing is only NaHCO3, that too 5 millimoles. Now, suppose if you add here methyl orange. Now the beaker contains NaCl, NaHCO3 and water. Now at this point, suppose if you add methyl orange, what will happen? This is the step 2. Step 1 is the earlier process and phenolphthalein addition, and step 2, if we add methyl orange to the above beaker after first end point. First end point means when we see the color change from pink to colorless, that is termed as first end point. That is the first end point. First time we are stopping it, we are ending the titration process. Now after that we are adding methyl orange into the beaker. Now when you add methyl orange, what happened? Already it is a colorless solution. Now when you add methyl orange treats sodium bicarbonate as a basic medium. So we know that earlier. See here, in the methyl orange case, we have seen this point, if you take, in case of phenolphthalein, this point falls in the colorless region, acid region, whereas the same point falls in the basic medium in the case of methyl orange. So therefore, the sodium bicarbonate which falls here, sodium bicarbonate, pH slightly greater than 7. So this point, phenolphthalein treated as acid and change to colorless solution from pink color, whereas methyl orange, when you add into the beaker, it treated as a basic point and changes the color to and gives color yellow color. So now when you add methyl orange into the above beaker after first end point, now color of the solution is methyl orange. I have not taken NaCl into consideration because that is just a neutral compound. It does not participate in any other further reactions. That's why I have not taken into consideration. Or we can write here also, it does not matter. Now here, methyl orange, when you add, it treats this compound as a base and gives yellow color. Now its solution is yellow. Now to this solution, now you add HCl from the burette. Okay. So this HCl solution which you are adding from the burette is a standard solution. That means you already know that its concentration. So whatever quantity, whatever thing you take in the burette and you add, every time you know its concentration because you prepared it. Therefore, you know its molarities. Now, if you add HCl into the solution, then what will react? Now, what reaction takes place is NaCO3, which is a weak base, and reacts with acid to form NaCl and H2CO3. And H2CO3 is a less stable compound. Therefore, it decomposes into H2O and CO2. So you will see the effervescence also in the reaction process. Fine. Now here, since earlier we have seen sodium bicarbonate, how much sodium bicarbonate is formed, Y millimoles of sodium bicarbonate is formed. So this Y millimoles participates in reaction with Y millimoles of HCl. Y millimoles of HCl require to react with sodium bicarbonate. Now after the reaction, since carbon dioxide is formed, the solution becomes acidic in nature, and this acidic solution will be resulting. Now because of that, the color of the solution changes from yellow color to, so now solution color changes from yellow to red. Okay, because it is an acidic solution, as it became acidic. So now once the solution turns red color, so it indicates the second end point. So you have to stop that process. You have to end the process of titration. So is the second endpoint. Since 2 titrations are used in this method, this is called double titration method. Okay, and the purpose of this double titration is only one thing. If there are unknown quantities are there in the beaker, you are identifying using 2 times titration. Now, so let's form the equations here. So there are 2 unknowns are there, NaOH and Na2CO3. So we need 2 equations. So let's go to the first beaker. Now in first beaker, what is the equation? Look, when phenolphthalein is used as indicator, what are the equations? Phenolphthalein case, that means when phenolphthalein is used as indicator, that means the first case where these 2 reactions are happening. Now here, can I say millimoles of NaOH plus millimoles of Na2CO3 is equal to millimoles of HCl till first endpoint, because first endpoint, whatever the total quantity of HCl you have taken, that is reacting with these 2 compounds only, and see X reacts with X and Y reacts with Y. So total amount of HCl, total millimoles of HCl is equal to millimoles of NaOH plus millimoles of Na2CO3. So that means here NaOH is X I have taken, so Na2CO3 Y I have taken. So this must be equal to total amount of HCl consumed. Let's say total amount of HCl consumed is A in this process, which is known quantity. Which you can find like this also. Suppose if volume of HCl added from the burette, which you can measure, burette is already designed, burette already, there is a calibration is there in the burette. So you know how many ml of HCl you have added into the beaker. So this volume, which you can see physically on the burette, into molarity of the HCl. Since you have prepared it, you know its quantity. So since these 2 are known to you, you can calculate the millimoles of HCl and equate it to X plus Y. So here I am writing X plus Y is equal to volume of HCl added into molarity of HCl. So this is one equation. But one equation is not sufficient to solve the problem, because there are 2 unknowns X and Y. We need one more equation. So that's, for that we need the second case. The second titration method when we use, as we see here, the second titration process, can I say using when methyl orange is used as indicator, we are writing now here the equation. Now the millimoles of sodium bicarbonate, because that is what the reacting in the second process, it must be equal to millimoles of HCl added from the burette second titration process. So what is the millimoles of NaCO3 reacting here? Y. It must be equal to the HCl which is added in the second case. So let's take HCl added is VML or V2ml. Let's call it V2ml here. And molarity, let's take same HCl which you have prepared and used in the first titration. Let's say same HCl is used. So that is take MHCl. So this both things are known to you. So this is the second equation. Now by using these 2 equations, this is one equation and the other one which you have written here, this is the first one. By using these 2 equations, you can now calculate X and Y values. So like this, you have to solve the double titration equations, double titration problems. Now here, one more variation is there in this double titration problems. Sometimes they will give a reaction like this. They will take NaOH, Na2CO3, and they will take they will add phenolphthalein into the beakers. Then after that, they will titrate with the HCl from the burette. So then in that case, we know what is the equations. We know what is the equation. Suppose if this is x, this is y, x plus y is equal to V1 into molarity of HCl. Okay, this is the first equation. We know how to form this. Now, then after that, what they do, then the step 2, this is step 1. Titration, this is step 1. Now in step 2, earlier what we have seen, after the first step, they will add the methyl orange into the beaker further. Okay, once a sodium bicarbonate is formed, then they will add the methyl orange into the beaker. But here in step 2, they may give that they will take the original solution only and they will add the methyl orange. For example, as a step 2, they will take again original solution, similar solution, which contains NaOH and Na2CO3, and this also X and Y again. And now, but instead of phenolphthalein, they will add methyl orange and they will titrate. So one case is, one type of problem is, first they will add phenolphthalein, then once the NaOH and converts into NaCl, Na2CO3 converts into sodium bicarbonate, then they will add methyl orange into the beaker. That means one after the other. Now here what they do, it is the second type of problems where they will give first phenolphthalein they will use and one equation they will form, and second the similar original beaker they will take, original beaker only, okay, and now they will add methyl orange from the beginning onwards. Then what will happen? Now HCl will consume. In this case, directly if we add, NaOH will first react with HCl to form NaCl and water. Then after that, Na2CO3 will react to form NaHCO3 and NaCl. And NaHCO3 after that again reacts with HCl, because here phenolphthalein is not there in the beaker to change its color to colorless. Only methyl orange is there. So therefore, after forming NaHCO3 also, methyl orange does not change its color, because for methyl orange sodium bicarbonate is a base only. So original also base is there, and now also sodium bicarbonate is also, it will treat it as base. So therefore color will be remain as a yellow color only. But once the total one converts into H2CO3, sodium bicarbonate further converts to H2CO3, then there is a change in color. Now the color is changed to red color. So after all these three reactions, only color change is seen. Now therefore here the equation will be X plus Y plus again Y, because Na2CO3 is reacting once, and the product NaCO3, which is Y forming in the first step, when Y of Na2CO3 reacts, you will get sodium bicarbonate Y, and this Y is again reacting with the HCl. Therefore X plus 2Y is the total volume, molarity of HCl, volume of HCl here into molarity of HCl. So that is what the reaction here. Suppose if you call it as V2 into M, X plus 2Y is equal to V2 into M, and this is the one equation and this is the first equation. You have to solve here these two equations in order to get X and Y. So therefore there are two kinds of problems you will see. One is case 1, type of problem, model 1 I will write, where first you will add phenolphthalein, there is a beaker will be there, and you will add phenolphthalein into it, and then titration 1 you will do, then after that methyl orange you will add, then titration 2 you will do. So in that case, what are the equations are there? And after first titration, equation will be X plus Y is equal to V1 into M. After second titration, Y is equal to V2 into M. Solving these two equations, you will get X and Y. Now model 2, second model is, you will add, you will take a beaker, but two similar beakers you will take. Okay, two similar original solutions you will take. So here also XY is there, NaOH and Na2CO3, and second beaker also XY is there. Now when you add phenolphthalein, first you will add phenolphthalein and you will titration 1. Then after that, second beaker you will take and you will add methyl orange into it and you will conduct titration 2. So 2 titration, double titration only, but it is a different manner they conduct. So in this case, what are the equations here? Here, like earlier model, it is x plus y is equal to v1 into m. That is one equation. And whereas second case, x plus y, that means x plus 2y, because now here NaOH will react, Na2CO3 will react to NaHCO3 and NaHCO3 will further react. So x plus 2y is equal to v2 into m. Okay. So here in this model, these two equations you have to solve, this equation and this equation, in order to get the x and y. Whereas in the model 1, these two equations you have to solve in order to get x and y. So like this, there are two models are there. Let's say a sample problem. Here there is a solution containing Na2CO3 and NaOH, requires phenolphthalein as indicator. Okay. So this is, let's take x millimoles, or let's take this one as y, because earlier we have in the explanation process we have assumed it as y. Now for this better understanding, let's take it as y millimoles, and this is x millimoles. Let's take, now requires this much HCl for phenolphthalein as indicator. So we can write an equation for phenolphthalein indicator. So what is the equation here? X plus y is equal to volume into molarity. So in case of HCl, molarity and normality are same. So 0.2 normality means I can take it as 0.2 molarity. So molarity of HCl. So that means x plus y is equal to 300 into 0.2 molarity, which is 60. So this is one equation. Now let's take the methyl orange case. Now in methyl orange, what they are doing, methyl orange is then added to above titration. That means it is model 1 question. Okay. After phenolphthalein titration, to the same beaker you are adding methyl orange. Then what happens? We have seen that y is equal, then equation will be sodium bicarbonate alone will react. So y is equal to V2 into molarity of HCl. So which is 300 into, and see here in this case they are giving molarity as different. That means they are not using the same HCl in the second time burette. They may change that also, but normally in laboratories they don't change, but it is up to you whether you use the different HCl in the second time titration or same HCl. But here in this problem they have given 0.1 normality HCl, so let's use that only. So 0.1, so that means 30 millimoles. So y we know and x plus y we know, so let's calculate x. So x is equal to 60 minus y. So this is y we already calculated. So 60 minus 30. So 30 millimoles. So we know what is the millimoles. So what is asked here? Well, calculate the amount of NaOH. Whenever they ask the amount, remember they are expecting the answer in terms of the mass. Okay. Unless they mention in the problem it is a millimoles or moles. When they just leave the question like this, amount of NaOH, they are expecting the answer in the terms of mass. So calculate that. So we know that mass of NaOH therefore is equal to 30 millimoles into 10 power minus 3. Now we will get that when I convert millimole, when I multiply millimoles into 10 power minus 3, I will get moles now. Okay, so this is the moles. Moles into molecular weight of NaOH will give me mass in grams. So let's do that. So 30 into 10 power minus 3. Now this is the moles multiplied by molecular weight. Molecular weight of NaOH is 40. So you will get this is as 1.2 grams. So answer for this question is 1.2 grams of NaOH is present in the original solution. Okay, they may ask you what is the mass of Na2CO3 also, which you can calculate. But since you know y, from using y, you can calculate the mass of Na2CO3 also. This is one model. In the second model, see, as you see here, there is a solution is there, Na2CO3 and NaCO3, and phenolphthalein, using phenolphthalein, they are titrating first. But see here, the same amount of solution, they are not adding methyl orange to the first beaker. They have taken the same amount of solution as the original one, and now they are saying it requires HCl when methyl orange is used as indicator. So in this case, again double titration, but it's a second model question. So when you use phenolphthalein as indicator, so what are the equations you have to form? X plus Y is equal to V1 into molarity of HCl, which is 150, given in the question as 150 into 0.3. So which is 45 millimoles. This is the first equation. X plus Y is equal to 45. Now second equation is what? Second equation, when methyl orange is used, so this is the HCl consumed here. So here X plus 2Y is equal to volume of HCl into molarity of HCl, which you have to use. That means here 425 into 0.2 molarity. So if you calculate this one, you will get 85 millimoles. So now these two equations we know. Now let's solve these equations. Now since X plus Y is 45, I can write here Y is equal to Y plus X. X plus 2Y I can write like this now, Y plus X is equal to 85. Now if I take X plus Y that side, Y is equal to 85 minus X plus Y. So X plus Y I already know 45. So 85 minus 45, so which will be 40. So if Y is 40, then I can calculate X. Since X plus Y is equal to 45, I can write Y X as 45 minus Y, which is 5 millimoles. Now once I know X has 5 millimoles, let's calculate its mass. So mass of NaOH will be 5 into 10 power minus 3. This is the moles into molecular weight of NaOH. Which is 40, and from this you will get 0.2 grams. This is the NaOH. So that is how you have to calculate in this double titration process. Dear students, if you really understood the concept and if you think you really benefited from this video, then please subscribe, like and share this video. Dear students, if you want to take full benefit of these classes, join our interactive live online classes by calling the phone number displayed on the screen. Thank you.